Hello everyone, so today I'm going to be salvaging all of the useful parts out of a microwave. I've never actually thrown away a microwave ever, because there's just so many nice things inside them to salvage for electronics, for other things, and well, you'll see all the fun stuff we get in it. Really, you only need maybe 2 screwdrivers, but this will be helpful. This will be helpful. And this we'll also use at a later time in the video. So let's start taking it apart here. So first we're going to take the back off. This is attached with not very many screws. We put one security bit on to make it hard. And it's a real security bit. Take a look at this. Oh, isn't that just an evil, evil screw to have to take out? There's a trick to these. If you have a good pair of pliers, or actually side cutters are best, you get it just right. Or you can even grab it from the inside. You just have to loosen it. Be careful not to break your cutters. Once it's loosened enough, you can get it out by hand. That should be the last of our screws. Alright, so the top should come off just easily now. Might need a little bit of persuading if it's too gunky like this one is. Alright. This is kind of sharp. Appears to be still connected somehow. Just like that. That's all you have to do. Just have to pull it off like that. Alright, and the main thing is disconnected. Now, we have all the main electronics here. Alright, so we have the Magnetron here. This is what generates the microwave energy. Actually, this microwave looks like it's in perfect condition. It's probably just dirty, but somebody cut the cord off. Not sure why. Some people, I guess, people just like to cut cords off. Whatever. This here is a thermal overload sensor that will manually, physically disconnect the electrical circuit if it gets too hot. Once it cools down again, we'll connect again. This is potentially very dangerous, but you can see it's got a big bleeder on it. This here is a bleeder, but to make sure, you always take a screwdriver, insulated screwdriver, and short out the 2 contacts. Make sure that this big capacitor doesn't have a charge in it, because this thing's deadly. So here is our main power transformer. We have a little light that makes the light light up inside it. A bunch of door interlock switches. Choke here. Fan. This is what keeps the microwave Magnetron cool, and also allows you to get air in through the microwave and out the back again. Actually, I'm pretty sure the air comes in through like that normally. So, is there a direction marked? I don't see a direction marked. So, we'll take a look at it from a slightly different angle here and see if there's anything else. Well, there's basically only a couple of things that I want out of the microwave. I'll keep this, the capacitor, the fan, this here, and I will remove a couple of very large magnets from here. We'll probably keep this circuit board, We might as well keep that and the thermal overload sensor as well. No. Now we just have to basically take all the pieces out. Some of these are held down by bent tabs. Unbend them. It really does come apart fairly easily. Everything is screwed together with easy to remove screws and little tabs. So we got a bolt down there to remove and a bolt down there to remove to get the Magnetron off. Now, I'm normally careful with these, both because they're sharp and because they can have some of them. I don't know if this one, I don't know which kinds, but I've heard that some of them have beryllium metal in them, so I try not to break them ever. Beryllium is very bad for you. If inhaled, I believe it can cause lung cancer or something like that. I don't know. That's what Wikipedia is for. And I'm not on a computer right now. I'm taking a microwave apart. There's one main bolt. Actually, there's only one bolt. The other one is held on by tabs. Take this off here. These are the main high voltage lines from the power transformer. That should be rated for about 4,000 volts. Alright, so here we have the Magnetron. And we're taking two things out of here if we can get at them easily. This has two high-powered ceramic magnets in it. Put this aside for now. Take the magnets out of there. Alright, let's see what we can do to get this apart. A few screws on it. I'll just take those off and see what happens first. Most of these are connected together by bent over tabs. So if you carefully unbend the tabs, you can often get them apart. Let's just see. Yeah, so we've got bent tab, bent tab, bent tab, bent tab, holding the main assembly there together. This is very soft metal. So if you cut in the exact right spots, it should come right apart. We'll cut it. These little tabs there. It's kind of soft, but you have to be careful. If they're really strong, you can break the pliers, so it might be better to use the bigger cutters for this. There. That's one tab off. So use a little bit of brute force to cut through it. You just have to be careful because I wish I had the left glove for this, because the metal is sharp. There we go. Top of it off. Take off the shield here. This is probably just brass. It's not ferromagnetic. And then we have a second shield between the magnet. We can probably just pull that up very carefully. The lever in there. Use that to push that up just a little bit. Now we can get the screwdriver between that. See, it's steel, so it's being held down by magnet, of course, not by. You gotta be careful, these are very easy to chip and they'll immediately start collecting metal filings. Well, that's the first one out. Now, this is just a heat sink, so pull the sides, pull this side of it first. You got it connected. you're not connected. So right now, the wires up there. The Magnetron is coming out. What you're doing is right now is, oops, move that away. There's a coiled copper wire on the inside of this that you're stretching out as you pull the Magnetron apart. Then bend these a little bit up more easily, and then once we can reach it, go right in there and snip the two copper wires. At least they look like they're copper. I'm not sure. They're probably copper because it's not that high of a temperature in there. Alright, so now this should come right off. Alright. We have our second magnet. Now we have both magnets free and they are very strong, so we're not going to put them together. Alright, now to keep these in their pristine condition and keep particles off, like there's already particles on it, probably from my glove, but there's particles everywhere. Every tiny little piece of metal jumps onto these. So, and also to prevent them from chipping, so you can use them on a fridge, make it so they don't scratch things. All you have to do is get some nice high quality electrical tape and wrap it nice and snug all the way around, alternating like that. Do the other one here. Two magnets. Now if I'd done that without the tape on them, would have definitely chipped them and damaged them. And doing that would have pinched my finger and hurt probably a lot. Now they're safer to use, they're still really strong, and they're more durable. If you want, you can put more on or less on, whatever your preference is. But beware, if you grab sharp things, it will dig into the tape pretty easily. So that's two magnets salvaged out of the microwave. So we'll continue on to see what else we can grab. They most definitely are not kidding with that warning label. It is capable of putting out somewhere around 4,000 volts AC, which is more than enough to kill someone by stopping their heart and putting them into a ventricular fibrillation or something like that, you know, that needs a defibrillator to restart. So don't play with these if you don't know what you're doing. So just take out the remainder of the couple of screws. Take off the capacitor here. Now, when storing capacitors, it's always a good idea to short them out, especially if they're extremely high capacity or high voltage. This one is fair capacity, but it is pretty high voltage. You'll see on the side here once I get it out. And remember, I have already grounded this with a screwdriver. So very important to do that. So here we have the high voltage capacity rated for 2,100 volts AC. That's not a toy. So we're just going to put that like that. Jam those together there for storage purposes. Alright, so next let's take off this fan. That's on with two little screws here. We can actually reach with the drill this time. Probably the cheapest drill they sell. I believe I got it a couple of years ago for $29 new. I was on an extreme budget and I needed something that spun around for a project. Did not need a drill. Let's just cut these little zip ties on here. Isn't this better than a fidget spinner? You can even feel a little breeze from it. Spins for an okay amount of time. And if you hook that up to regular 120 volts AC, it works just fine, but it's kind of hazardous to do that, like without a case, because you see all the wiring is exposed. Fan is exposed. It could be rather dangerous. I remember having one when I was 5. Here's the board with the fuse up close. One thing I love about microwaves is almost pretty much everything in them is put together using simple spade connectors. It's all completely modular. Like, look at that. It just came all unhooked without cutting any wires. Next, take off the wiring on the light fixture. Here's our lamp. Take off the wiring harnesses on the door switches and one of the relays. And then we have here another door switch. Yet another door switch. They're not kidding around when they want to make sure that the door is shut. These ones are a little more difficult to pull off. They're smaller. There we go. There's one. Now we've almost got down to the transformer. Let's remove the power from the controller circuit board. And wire power from the main transformer. That goes to the turntable, so we're not going to worry about that right now. Now, take a look at this cable. This is not ordinary plastic cable. This is more like fabric. It's a very rigid, high voltage. Inside this cable is solid core copper wire instead of the normal solid, like multi-stranded copper wire that you see. It's just a solid wire. And it's got this very fabric-y feel to it. It's actually pretty neat. Now we have to flip the whole thing over and remove the bolts from the bottom right here. And then this whole transformer will fall right out. There we go. Transformer removed. Now this is probably what we have here. This is the primary. Main voltage from the wall comes into that. It goes into the secondary, which will have much smaller wire. Yeah, see the difference in the sizes? This one has way less turns, so it steps the power up when you put electricity through that section of it. So these are very good for paperweights, like holding up books, using as a hammer. Also, these coils are useful. You can chop it apart, pull out the coils, use a bunch of them to make a windmill, along with the magnets and some iron, or some of the iron core from the magnet from the transformer. Alright. I forgot to actually check if this thing does have a turntable. It does. Alright. That's one of the other really cool things you'll find in a microwave. It's a turntable motor. Turntable motor is typically a little more difficult to get at than everything else. You have to take that entire frame apart. At least for this model you do. Those are bolts. Now this is an ingenious little thing. This is a 2-watt, 120 volt AC motor. Meaning that if you turn this, you're going to be generating quite a bit of energy out of here. In the range of, depending on how fast you go, like if I hook this up to the drill, I'm not going to touch it. It's going to be generating a couple hundred volts. Let's get the voltmeter and try that before the battery dies on here. Alright, so this is actually kind of dangerous, especially if you were to be stupid and hook it up to some of the other things we pulled out of this thing already. But this will give you an idea of the amount of electricity you can get off one of these. In low amperage, of course, but in enough to matter. There's 100 volts right there. 100. It's hard to make. There's 60 volts. Okay, there's. It's very easy to overpower the gearbox in there, so you can't put a whole lot of torque on it. But yes, you did just see that correctly. Over 200 volts. Yeah. These little buggers can be dangerous. Especially if you hook it to a bridge rectifier and bank of capacitors like I did in a different video a while ago. I'll link that in the corner here. So the last thing I'm going to do here is just pull out this logic board. Don't really need the buttons. Ooh, look at that display! That one looks very cool if reused in some manner or form. And it would be very easy to do so. I think that's the controller chip there. It's covered in some kind of gunk, so it's hard to read. There's a buzzer there that makes the beeping noise when your stuff is done cooking. This is interesting. This is a relay, but I haven't seen a lot of relays with stuff coming out the top and the bottom like that. There's a little transformer, another relay. Not really all that complex of a... Last thing, just pull out these switches here. This whole assembly comes out. Interesting, eh? That's what the door goes into. The door switches, like, it pushes through and activates it somehow. Complicated, not too complicated, just put position. These are all held in with tabs. Not difficult to remove. Alright, so from this microwave we were able to salvage a nice little logic board with a display on it, a lamp with lamp holder, high voltage capacitor, 2 strong ceramic magnets with a nice pile of miscellaneous screws. Screws are actually expensive. Thermal overload sensor here. There's a thermal overload sensor. Rated for 105 degrees Celsius. We'll just open up and stop working until it cools down. And we also got the switches. Got a wiring harness here with useful spade connectors on it. Big power transformer. A little choke input fuse board. And a fan. 120 volt AC fan. Well, thanks for watching my video about taking apart a microwave and salvaging the parts. I could never tell you when was the first time I took apart a microwave. I think I was about somewhere around 5 or 6 years old. My dad assisted with the removal of the capacitor and stuff like that, of course. And this was before turntable motors, so there wasn't one of these to be dangerous around. I never did really do much with the transformer. I think my dad may have taken the transformer too. I don't remember. I was like 5 or 6 years old. But yes, I never let a microwave go to waste. Always many useful, salvageable materials inside of a microwave. Anyway, thanks for watching. And maybe take a look at the video where I spot welded a penny. I spot welded a piece of copper into a penny using one of these and a couple of capacitors and a bridge rectifier. See ya.